of titrant added. Typically, the titrant is a strong or completely dissociated acid or base. Such curves are useful for determining endpoints and dissociation constant of weak acids or bases. Now, I have a titration curve for strong acid and strong base titration here with me. And when you look at this, you will discover that the equivalence point is at 7.0. That is where the hydronium ion H3O plus OH minus react together to form H2O. You know that when titration is over, there will be what? There will be salt and water left inside the conical flask. When you have your acid and your base, there will be formation of what? Salt and water. Mind you, this salt is not edible salt, it's a dangerous salt though. So it's not what you can consume. Now, for this curve, you will see that the example of the acid used here is a strong acid. We have hydrochloric acid and we have a strong base, sodium hydroxide. Then we have H2O and NaCl. Before I continue, I would like to mention the apparatus that we use while we want to carry out acid-base titration. We make use of conical flasks. We make use of retort stand. We also make use of what? Pipette and burette. We also use indicator bottle. You must have your wash bottle with you with distilled water or any source of clean water. So when you titrate, you make use of all these apparatus. Let me come again. You make use of conical flasks. You make use of pipette. The pipette is used to draw the base from the what? From the container where your base is, the reagent bottle where your base is. And then you use the funnel to transfer the acid into the burette. You use the funnel to transfer the acid into the burette. So you make use of what? You take calculated amount of your base with the pipette. You release it into your conical flask. Then you add what? You add indicator. After you have chosen the suitable indicator, when you look at this titration curve for strong acid and weak base, you will discover that we can use both phenolphthalein and methyl orange, because there's a sharp point from where we have 4.0 to 9 to 8.5. Yes, and your methyl orange has a range of 4.2 to 6.5. So, and phenolphthalein also has a range of 7.5 to 9.8. So in that sense, 8.0 to 9.8. So in that sense, we can use both methyl orange and phenolphthalein to carry out our acid-base titration. But then it depends on the titrant. The titrant is the solution of unknown concentration. If it is the acid that is the titrant, then I will advise you make use of phenolphthalein. If it is base that is the solution of unknown concentration, you make use of methyl orange. So I want us to look at the four major differences between a weak acid and a strong base. Okay, we have only covered the titration curve for strong acid and strong base. Let's check the titration curve for weak acid and strong base before we do the comparison. Looking at this curve, you will discover that the equivalence point is at 8.80. almost at 9.0. So when you are carrying out a titration, I told you that the titration curve is a what? Is a plot of pH range against the what? The volume of titrant added. When you look at it very well, you will discover that the equivalence point is at almost 9.0. When it got to 6.0, it moved sharply to 10.5 before it curved. So in this case, we can use any indicator that falls between that range. And when you check the pH scale or the pH range, in that case is methyl red. Yes, is methyl red. Methyl red has, is phenolphthalein. Phenolphthalein has a pH range of 8.0 to 9.8. So from here it moves from 6.0 to 10.5. Yes, so we can use methyl red or methyl orange here. We make use of phenolphthalein because this is a strong base. So the titration curve also helps to know the suitable indicator that can be used to carry out our titration. Before we go for today, I want us to look at the application of titration. What are the uses of titration? Be it redox titration, acid-base titration, titration involving the chemical analysis of our food content. I want you to know that this titration is very useful in chemical industry. We use it to determine water content in solvents. We use it to determine acid value in resins and polymers. Polymers are organic compounds that are formed by joining smaller units of monomers together. And also, we make use of titration in food and beverage. You can use titration to determine the strength of acid present in fruits that we eat, like orange, pineapple. You can use it to determine the vitamin C content in fruit juices, and then chloride content in spicy sauces that we consume. Also, electroplating can be used. Titration is used in electroplating. That is when you use nickel content to electroplate bath, or you use gold to electroplate another compound in order to make an alloy. In chemistry, an alloy is a compound that is formed by the joining together of similar substances to make a better version than when they are individual components. So again, in pharmaceutical, we make use of titration to know the water content in raw products that are used in making drugs, and to check the purity content of those drugs. So that comes to end of today's class. Next week, by God's grace, we are going to continue from here. And big thanks to everyone for listening from Ibadan and beyond on Oxygen FM 96.9. This is Mercy ODEH. Join us again same time next week for more educative and interesting lesson. Until then, keep reading and stay curious. Bye for now.
Your community. Your radio station.
This is Oxygen 96.9 Ibadan.
Oxygen 96.9 FM rédíò tó milẹ̀ títí. Ọ̀gánikan láwùjọ òkúta. ilé rédíò tó ní ẹ̀mí titun ibẹ̀ láti sọ̀rọ̀ ìmọ̀ àti ìlera pẹ̀lú ìdàgbàsókè fún gbogbo ènìyàn má gbé kúrò. Kókà Oxygen 96.9 FM Oxygen.